Hello friends, in this video I'd like to solve the following problem from the Spanish Mathematical Olympiad, final round 1980. Problem number 5. We wish to prove that if alpha and x are such numbers that x plus 1 over x equals 2 times cosine of alpha, then x to the power of n plus 1 over x to the power of n equals 2 times cosine of n times alpha for every integer n. So my hints for this problem, the most obvious solution is to use induction, and keep in mind this nice formula for product of cosines. Twice the cosine of alpha times cosine of beta equals cosine of alpha minus beta plus cosine of alpha plus beta. So give this problem a try and I will see you in a minute. Okay, so I hope that you've managed to solve this problem. As I said, I will use induction first to show that our theorem is true for non-negative integers. So, induction over, let's start with non-negative integers. Well, let's consider first two cases. If n equals 0, then what happens? Well, x to the power of 0 plus 1 over x to the power of 0 is 2, and 2 times cosine of 0 alpha, well, it's cosine of 0, it's also 2. So it holds. If n equals 1, then x plus 1 over x equals 2 times cosine of alpha. Why? By assumption. It's true by assumption. It's our very assumption. So now let's consider, so let's assume let n be greater than or equal to, and assume that x to the power n minus 2 plus 1 over x to the power n minus 2 equals 2 times cosine of n minus 2 times alpha, and similarly, let's suppose that x to the power n minus 1 plus 1 over x minus 1 equals 2 times cosine of n minus 1 times alpha. Okay, and now let's consider x to the power n minus x to the power of n plus 1 over x to the power of n. Well, what happens? First of all, maybe let's do the following. Consider x plus 1 over x times x to the power n minus 1 plus 1 over x to the power n minus 1. What happens? Well, we know by our assumption that is 2 times cosine of alpha, and also by our inductive assumption, this equals 2 times n minus 1 times alpha. Okay, so 4 times cosine of alpha, cosine of n minus 1 times alpha is equal to what exactly? Well, let's multiply this parentheses. We get x to the power of n plus 1 over x to the power n minus 2 plus x to the power n minus 2 plus 1 over x to the power n minus just x to the power of n. Okay, and now let's look also by our assumption. This part happens to be equal cosine of n minus 2 times alpha. Well, that's something. And now we have twice the cosine, twice. And now we have the following. 4 times cosine of alpha, cosine of n minus 1 alpha, equals 2 times cosine of n minus 2 alpha plus x to the nth power plus 1 over x to the nth power. Okay. This part will stay the same, and now, using the formula which I suggested at the beginning of this video, this can be written as 2 cosine of n minus 1 times alpha minus alpha plus 2 times cosine of n minus 1 times alpha plus alpha. And that is equal to 2 times n minus 2 alpha plus x to the nth power plus 1 over x to the nth power. Very nice. And now let's simplify it further. This here is 2 times cosine n minus 1 alpha minus alpha. It's n minus 2 alpha. Here on the other hand we have 2 times cosine of n times alpha. And here we have 2 cosine of n minus 2 alpha plus x to the nth power plus 1 over x to the nth power. And now let's notice that this and this now vanish from our equation, and we are left with 2 times cosine of n times alpha equals x to the nth power plus 1 over x to the nth power. And that closes our inductive proof, because from the established or assumed equalities that our theorem holds in the cases n minus 2 and n minus 1, we derived that our theorem, our statement, is also true in the case of n. And that's why, because I have gone backwards 2 steps from n to n minus 1 and to n minus 2, I had to consider first 2 cases separately, not just one case, but 2 cases. Okay, so now we know that x to the power of n plus 1 over x to the power of n equals 2 times cosine of n times alpha for every natural number. What about negative integers? Well, if now n is a negative integer, then let's notice the following. X to the power of n plus 1 over x to the power of n, it's just the same as 1 over x to the power of minus n plus x to the power minus n. And now we have, again, positive exponents. So, by our assumption that our statement is true for every natural number, we know that this is 2 times cosine of minus n times alpha. But we also know that cosine is an even function. So it's just the same as 2 times cosine of n times alpha. And that implies that, in fact, for every integer, positive, negative, or 0, x to the power of n plus 1 over x to the power of n equals 2 times cosine of n times alpha. And that was our goal. We have now concluded our proof, and we have now concluded our video. So thank you for watching, and I will see you next time.